All right, so we got this data. Two options from here. One is write it on a piece of paper and then play around with it. I'm assuming the way the data was given that the first group of numbers are my x values and the second group of numbers are my y values. And when I plot these points, they look like they line up. So you should plot them to see that. I'm going to do that in a spreadsheet in a second. What I want to do is figure out, well, okay, if these are the x's and these are the y's and it looks like they line up, I should be able to find the slope. And so, for example, I'm going to go from the first point to the last point to find the rise and the run. So my rise for my slope in this case would be 16.2 minus 25.8, and I'll calculate that in a sec. And then my run for this data would be the 150 minus the 50. And if we put that all together as a slope, remember the y stuff has to go on the top. So I was believing my y's were those heights because I picked a weight. That's my independent pick. And then the weight made some distance on the ruler. So independent, dependent variable. So 16.2 minus 25.8. And then we have to divide that by 150 minus 50. So whenever you make a slope, you want to think carefully about, do you have the y values in the top? Right? Y in top. Do you have the x values in the bottom? X in bottom. And then the other thing is vertically, points need to line up. So points vertically. And if you do those three things, then your slope's always going to be right unless you type it in your calculator wrong. So whip out a calculator if you haven't already. Let's get a slope on this. So we'll get started together and then I'll set you free. And if you have a slope, feel free to throw it into the chat. All right, hopefully everyone's calculating out there. Still hoping somebody's gonna pop a slope out. Oh, here we go. Negative, I got a couple people through this in, negative 96 thousandths. That looks right from what I remember on my spreadsheet, which I'll look at in a minute. So negative 0.096. And I like to put the 0 in front so I can clearly see where my decimal is, because sometimes I make a little tiny poke on the paper. So I like a leading 0 and then the decimal. All right, so then what does it mean? Okay, so what are my y values? Are my y values heights or masses in this case? Y value. Height, right, and that's in centimeters. And then the x values, those are grams or centimeters? What are our denominator?
Grams.
Grams, yeah. So when I write my slope, what I have is centimeters per gram. So this number right here, centimeters per gram. If I wrote a sentence, I would think about that as negative 0.096 over 1. So that number would be centimeters and this number would be grams. So I could say something like, for each additional gram added to the spring, the height, H-E-I-G-H-T, will drop or decrease, some word for the negative. So I don't want to use the word negative. I don't want to throw in a negative sign. So use a word that means negative height. So I'm going to go for drop. Decrease would be okay too. The height will drop by 0.096 centimeters. So that would be a reasonable sentence for what this slope means. So this is an interpretation of the slope. And then we need to do a little jiggery-pokery to figure out what the y-intercept is. So I'm going to hold off on that for a second. What I'm going to do is just do a quick demo on how to do this in a spreadsheet. For those of you who are digging working with spreadsheets, or have in the past. So let's add a new one. And since the data is available on the page, if I carefully copy from the word mass over and down to the end of 1.62, don't copy too much, right? You got to stop and start at the right spots. Often when you copy and then go to your spreadsheet and paste, the spreadsheet accepts each thing in its own cell. If you highlight the wrong stuff, then you get this mess of crap. It doesn't necessarily work in every browser correctly. So it kind of depends on the browser. So I'm using Chrome and Google Sheets, and the copy and paste of the table worked good for me. If you accidentally highlight too much stuff and you try to copy it and paste, then sometimes weird shit happens. Well, that wasn't too bad. Okay, I got lucky today. All right, so here's my information in there. And I mentioned last week, and I did a quick demo of it, the computer has a slope function, so it can look at this stuff and say, hey, here's the slope. So I'm gonna show how to do that and see if it matches what we just did. But first I'm gonna graph it on the computer. So I highlight the data, I hit insert chart, and I pray it does the right kind of chart. No, it did not. So then for column type, I'm gonna say, I want some points, please. So I look down to where it plots points. That's called a scatter plot. Hey, that looks pretty good. And those line up pretty nice, okay? And so part of your assignment is to attempt to place those points on the grid. And when I did that, I had a hard time putting them in the right spot, like 50, 25.8. So I get the point tool, I go to 50, 25.8, and at first I missed, and then I would just drag it and I can put it wherever I want. So I try again, it's pretty close to there, I think. So do your best to plot those points there, and you can always move them around before you hit submit. All right, so they do look pretty straight. So now I'm going to try and find a slope, and there's two ways I could do that. One way is to just type the calculation we wrote on our paper, or I wrote on my paper. So if I was going to do that, I would just go equals parentheses for the numerator, and then I would take the second y value minus the first y value. So I just point and click, close the numerator, divide, parentheses for the denominator, and then click minus click. I should get that number we got earlier. I'm going to do that again, but using the way I showed last week, and I made a video and posted the video for it. If I type equals and start typing the word slope, the computer says, yeah, I can do slope. And then it says, okay, give me your y data. So I would highlight all of this. And then it wanted a comma right there. So I got to pay attention to what it shows me here. And then I highlight the x's. Now, in this case, I'm using all 3 points, which could give me a different answer than just 2 points. So that's a weird thing if the points aren't perfect. But I got lucky this time. Turned out to be the same. So sometimes when we have data that sort of kind of lines up, which 2 points you pick will give you a slightly different slope each time. Could be dramatically different. But here I got lucky. It was the same thing. All right, so let's see what I want to do. I want to stop this recording right there. And then, oh, no, I want to show one more thing. All right, so I'm going to put you into groups in a minute to finish this up. If you already finished with it, then you have the option of not going into the group to do so. I want to take a look at the next page here, which is the sinking wood page, and go over how I would set this up. And then I'm going to throw you into groups. So the key here is this information at the top. We have to pay close attention to what this says, which numbers are the most relevant. And then in the next thing, they give us some letters to use for variables, and we have to decide on independent and dependent variable. So I'm going to copy this into a spreadsheet so we can work with it. Screenshot. And I need all of this information there. New page, please. So often I've done this with other problems. When I get a bunch of information like this and I know I have a couple of variables, I'm often going to make a table. Come on, pen. There you go. Let's not use red. There we go. And I'm going to have some X's and I'm going to have some Y's, and I get to decide which is which. So usually I have to read this a few times to figure that out. So don't worry if you didn't answer all the questions about the spring. We're going to go back to that. I just want to give you some tips on the next one. So we have a block of wood, 10 centimeters by 20 centimeters by 4 centimeters thick, is floated in a pool of water, submerging it to a depth of 1 centimeter. A 50-gram mass is placed on top of the block, increasing the depth submerged to 1.25. Another 50-gram mass is placed on the block and on top and increase the depth to 1.5. So it looks like kind of like the spring. They keep putting more weight on and watch the block of wood sink. So what's independent is the amount of weight they're throwing on there, and then the block sinks more depending on how much weight there is. So it looks to me like in this case, the weight is independent because that's what they're adding to the situation. And then they're watching to see what happens, and what happens is the depth that it's submerged. And let's see, they give me, the wood is put in the water, so I have this block that's 10, let's say that's 10 right there by 20, so maybe 20 is like that big. So here's like the top of my block of wood. And then it's 4 centimeters thick. So that would probably be around this thick, maybe. So here's my block of wood. That's 10 by 20 by 4. Each of those is centimeters. But then it's sitting in water. And let's see, it's 4 thick, but it's only sunk 1 centimeter. So if I split this into 4 chunks, then there's water right about here on the block. So it's 1 centimeter underwater. So for me to figure out a problem like this, I got to kind of draw pictures and write a whole bunch of stuff down. All right, so if they put a weight of 50 grams on there, it ended up at 1.25 centimeters. If they added another 50, so that gives us a total of 100, I think. The depth is 1.5. And then the depth of 1 was the block with no extra weight. So I would say that depth of 1 right here goes with no extra weight because it's after they start putting weight on it and I get more depth. So the block of wood is sinking when they put more weight on it. So one kind of cool thing here, notice I have a point with a 0 for the x value. That means this 1 right here must be my y-intercept, my value for b. Oops, intercept. So that's kind of cool. So all we have to do is figure out the slope here, which we could do by hand with a calculator or in a spreadsheet. Okay, so I'm going to shut up now. I gave you guys, I think, a really good start on this. I'm going to stop recording.